Yes, okay, very good morning. So it is in the last class I have explained about the magnetron. Okay, so it is concerned to the unit 1. It is of the advanced communication. It is for the ENC branch of the diploma. Okay, so and in this class we are going to study about the TWT. It is traveling wave 2. Okay, and in this TWT, okay, so that we are going to study about the construction, its operation, and the applications. Okay, so that if you see the so if you see the definition of the traveling wave tube, okay, so that what this traveling it is what this traveling wave tubes are the broadband microwave devices, and it is not having the cavity. It is exactly same once again like the clystrons there. Okay, so that if you see the rectangular wave tube, or if you take the circular wave tube, so it is having the cavity here. But if you take the cleistron, so that it's not having the cavity. In the same, it is once again in the same way, it is a traveling wave tube. Okay, so it's not having the cavity here. But if you take the cleistron, so according to the inlet and the it is outlet, it is consisting of the two cavity, or it is of the multi cavity. It is one is the bunching cavity, another one is the catcher cavity. But in case of the TWT, so it's not having the cavity here. Okay, and the amplification is to be done through it is the prolonged interaction between the electron beam and the RF field. RF is the radio frequency. Okay, and if not means you can see that this is the diagram of the TWT. It is actually visible in this way. Okay, and so understood. So if you take the traveling tube, it is nothing but the microwave device. Okay, it is used to travel the signals. Okay, whose frequency is from 100 megahertz to 100 gigahertz. So it is called as of the microwave device here, and it's not having the cavity. It is itself is called as of it is TWT. And in this case, its operation is to be based on the interaction between the electron and the radio frequency. It is based on that, so it undergoes the operation of the amplification here. If you take the construction of the traveling wave tube, okay, so it is the traveling wave tube, its internal construction here. So it is consisting the outer as an external tube here. It is made up of the metal or the glass here. It is an external. And after that, so inside it is consisting of the cathode tube here. Okay, so that you can able to see the cathode here. Okay, and it is internally, or it is internally located inside the what electron gun. Okay, so that you can able to see this is the electron gun here. Okay, and after that you can able to see the dotted line. Okay, it is the anode plate here, and it is to be followed by the coil here. Okay, it is called as the what helix. Okay, and it is used to decrease the speed of the electron. And after that you can able to see it is one is the input port and the another one is an output port. In this case it is called as an inlet and the outlet, or only as an input and the output. So it is used to input the RF frequency here. Okay, RF signal. And after that, at the other end, it is consisting of the collector. It is used to collect the electrons, okay, which is emitted by this cathode here. Okay, so if you take the traveling wave tube, it is a cylindrical structure. It is which contains the electron gun. It is from a cathode tube. So that you can able to see this is the cathode tube. Internally, it is consisting of the what electron gun. This is an electron gun, and it is used to emit the electrons. And after that you can able to see the dotted line. It is acting as the anode plate. It is used to maintain the electron exactly at the center of the tube, at the center of the tube. And it is also consisting of the what Alex. Okay, it is used to decrease the speed of the electron. And after that, it is consisting of the collector. It is used to collect the electron, this which is emitted by the cathode. And after that, it is consisting of, it is one as an inlet and the other one as an output. So inlet is the one at which the RF okay, the signal is to be inputted, and the outlet or the output is the one in which the amplified RF signal is to be taken outside. Okay, it is the construction of the traveling wave tube. It is a traveling, okay, wave tube. Okay, it is TWT. And after that, if you take its operation or if you take its working principle, okay, so the anode plate, it is one at the zero, it is potential, it is, which means it is when the axial electric field is at the a node, the electron beam velocity is going to be remain unaffected. So it is, that means that you can able to see that it is the what, Lx. And you can able to see this is the anode plate, and if it is to be connected at the zero voltage, okay, so that you can able to see it is to be connected with the positive voltage. And what this okay, coil, it is also to be connected with the positive. And if this voltage is equal to zero means, okay, so the speed of the electrons is unaffected. Okay, it is going to, it can able to travel in its own speed. And after that, so it is when the wave on the axial electric field is at the positive antinode. So if you apply the positive voltage, it is at the anode plate and also for the coil. So the electron, it is from the electron beam, it moves in the opposite direction. Opposite direction means, so if you apply the some amount of the voltage for this positive terminal of the anode and also for this coil means, it is going to decrease the speed of the electron, okay, which it is moving. And after that, in the meantime, if you apply the RF input here, okay, it is going to be get combined with this existing electrons, and it is going to increase its intensity, and it is going to form the bunches. It is going to form the bunches as in this way, okay, so that you can able to see the bunching here. Okay, it is so it is to be represented with the dots here. And after that, it is going to increase the number of the electron, and it is itself is going to be combined with this RF input voltage, and afterwards it is going to increase its intensity or the amplitude level, and afterwards it is to be moved along with the coil, and afterwards it is to be taken outside from the output port. So if it is to be taken in, it is in the output means it is in the amplified manner. Okay, so this RF is to be inputted in the inlet, and it is to be get combined with the what, electrons, it is which is emitted by the electron gun, and afterwards it is increasing its strength here, increasing its amplitude level, and afterwards it is to be taken outside. So the RF output obtained is in the amplified manner here. Okay, this is itself is the working principle. It is itself is the operation of the traveling wave. Okay, and if you take the applications of the traveling wave tube, it is mainly used for it is point-to-point communication. An example is the phone. It is also used in the satellite communication and the radar. It is also used in the missile tracking applications for the military applications. It is also used in the television. It is for the broadcasting purposes. Okay, all these are the applications of the traveling wave tube. Okay, so I think you have understood. So in this class, I have explained it is what actually the TWT. It's nothing but the microwave device. Okay, and it is with the no cavity. And in this case, the operation takes place with the interaction between the electron beam and the RF. Okay, if you take the construction of the TWT, it is to be implemented with the outer, okay, cylindrical structure. Either it can be made up of the glass tube or any of the metal, and inside it is consisting of what, it is cathode tube, and internally it is consisting of the heater or the what, electron gun, and it is used to emit the electron, and it is also consisting of the anode plate, and it is used to maintain the electron exactly at the center of the tube here, and it is also consisting of the coil. It is called as the helix, and it is used to decrease the speed of the electron, and the input, it is used to apply the RF input, and the output in so in which the RF output is to be taken outside, and in this at the other end it is consisting of the collector. It is used to collect the electrons. And if you take the operation, okay, so what this the cathode, it is used to emit the electron, and if the voltage at the anode and the coil is equal to zero potential, means so the speed of the electrons is unaffected, and if you apply the some amount of the positive voltage, it is going to decrease the speed of the electron, and afterwards it is with the input, it is going to input the RF signal, and RF signal is to be get combined with the electrons, okay, and it is going to form the bunches, and in the form of the bunches it is going to move also along with the coil, and it is to be taken at the output in the amplified manner, so the output is to be taken at the outlet, okay. In this way the operation takes place. Okay, and it is if you take the main applications in the point to point, in the satellite communications, in the radar, and in the military applications, and in the broadcasting, etc., etc. So all these are the main applications of the traveling wave tube. Okay, if you take the possible descriptive questions on on this concept is, so that he may ask you to explain the construction and working principle of the TWT, or he may ask you to list the applications of the TWT. Okay, so it is with this also the entire unit 1 is completed, and in the next class we are going to start the unit 2. It is a radar. So okay, thank you.